Okay, so that is the first usage, EMBB, okay, used by a lot of scenarios. And second is about the smart grid. Now, smart grid. So smart grid means the electricity grid, electricity supply network, okay, called grid. Okay. The trend for the grid is that it is migrating from one direction to multi-directions. One direction to multi-directions. What does it mean? It means that in the past time, okay, the grid is providing the electricity to the end users. So it's single direction, okay, from the power, okay, electricity supply network to the end user. Okay. But nowadays, a lot of users now, they can generate electricity by themselves by using solar or by wind. Okay, so when there is sunshine or there is wind, okay, they can create electricity and supply to themselves. And they may also feed their electricity to the network or to other users. So now we need more than one direction. Okay, when they are not generating power, the network needs to provide power to the user. Okay, and when the user are generating power, they can feed back their power to the network, or they can feed the power to other users. So we may need multi-directions for the electricity, not single direction any longer, okay, in this case. So migration from one direction to multi-directions. Okay. And also from centralized to distributed. So in this case, this generation of power, okay, they got distributed in different positions, okay, in the network. And then our network can need a digitalization and automation. We want to have the automatic control, automatic monitoring, digitalized, okay, network. And there are a lot of new energy form, just for that solar, wind, okay. And also nowadays there are a lot of new energy vehicles. They need charging, recharging for electricity. And there are a lot of recharging piles in the city. Okay. It needs a power supply also. So this becomes more and more important in the daily life. So it's about the trend for the grid. And this has bring us some challenges for the network, for their network. They have new trend. So the challenge is that, first one is that if you use fiber, it's very expensive. Using fiber for communication is very expensive. So we need some communication which is cheap solution. Okay? Using wireless communication is the most suitable way to lower the cost. And also is that 90% of the power outage happened at the last 5 kilometers, not at the beginning part, not at the generation, okay, transmission and transformation, not at the very main part. It's at the edge of the network, after the distribution, okay, to the users. Okay. Most of the problem of the grid is at near the end, and there are many these kind of stations. Number of the stations, the size of big number. Okay, we want to realize the communication to there, so you need a big amount, quantity of the communication connections. Okay, this is a huge amount of investment actually. Okay, and the intelligent transmission is the key. Okay, for the power supply reliability. So we just know that there is no effective, low-cost, wide area network communication solutions because the fiber is expensive. Fiber is expensive. And using wireless way, actually 4G is considered. 4G is considered, but 4G's latency is not good. 4G latency is around 30 to 50 milliseconds. So for some isolation, this time it cannot meet the requirement. Okay. So 5G is considered as a better solution because 5G can have the slicing function. Okay, we can make a slide dedicated for the grid. It has the high requirement on the security, isolation, and reliability. This is similar to even similar to a military network. Okay. So slicing to guarantee the security and isolation and reliability, we need to slice not only the wireless network, the core network, we also need to make the slicing in the transmission network. That will end the slicing, okay, to guarantee the reliability for the grid. So here is the chart diagram for the grid from the end to end. One end is for generation, okay, this factory generating electricity, okay, and to the transmission network, the main network, and then transformation. The voltage becomes lower, okay, and then to the distribution network, and then to the users, to homes. So these 3-1 we call it A plus area, A plus. Generation, transmission, transformation, A plus area, very important. Okay, and most these areas are using wire line, fiber, optical fibers, wired. Okay, and the wireless is only a supplement for the main communication method is using optical fiber. And for the distribution network, these we have a huge number of terminals there. Okay. Many of such stations or sites. Okay, and we need the communication there. And because the number are very big, it is incredible using fiber for the communication. So the most suitable way is using wireless. Now, for worldwide, only around less than 10% is connected with fiber. In other words, to say more than 90% are not connected with fiber because it's too expensive. Too many number of such stations, too big of investment using fibers. Best way is using wireless. Okay? The wireless can save 70% of the cost. And about the homes or the users, they were mainly using the metering, automatic metering infrastructure. Okay? Intelligent reading. So these are different position or scenarios of the grid. And the different position, even different service, like this A+, they may need surveillance, monitoring these transmission cables, okay. And they may need scheduling communication, okay, scheduling of their workers or their engineers for technical issues. And in the distribution network, they need the distribution automation. It means that they can monitor their devices and they can also control their devices. And the control delay will require to be very low latency, okay, because the network is electricity network is very important. Okay, for example, some place there is a problem, then we need to cut down that part immediately. It's called isolation. And this responding speed is in millisecond level. And for the user part, we need smart metering. Okay, so the different services needed at the different places of the grid. Okay. And here lists some typical services like the distribution network protection and control. Latency, end-to-end latency, 100 millisecond, okay, millisecond level. Bandwidth is not too much. So it just need low latency. Okay, URLLC is the typical usage scenario. Okay. Time service, okay, timing service, also very small delay in this case, URLLC. And for some scheduling, this is using eMBB, okay, because it's broad video related, okay, or voice related. Smart metering Smart metering, just many meters, reader, many homes, many reading of the meters. So the connections are very big number, but they do not need very much of the bandwidth or latency. So that is very typical for MMTC. Okay, MMTC. And the video surveillance and mobile task, these are the scenarios here maybe. So you can see that for the smart grid, all types of service scenarios are needed. Of course, only 5G can meet the requirement. Okay, using 4G, some services type like URLLC cannot satisfy the requirement. Okay, and so this is also the network. This is for transmission, distribution, and the usage. And for the transmission network, they are using fibers, fiber networks. So these do not have too much market share for 5G. 5G cannot take too much market share in this area because it's the playground for fibers. And 5G can come to the role in the distribution network. For the automated power distribution. This is for the URLLC, mainly for the URLLC. And there are some more solutions, old solutions like ELTE. ELTE is the enterprise LTE. It's similar to LTE. Air interface is the same. So this one, bandwidth is okay, but just for sometimes the delays cannot meet the requirement. Okay. And the 5G, better. 5G can short latency. And in the usage part, the main job is the meter reading, IoT, okay, Internet of Things. Okay. MMTC for 5G is better. Of course, except the 5G, 3G and 4G or even 2G can also be applied in this one because its requirement for the communication is not very high. Just requires large number of connections. So for 5G, the main market is about these two parts. One part is the distribution network. Another side is the usage. And the smart grid has a very high potential of the demand, very much. Okay. And here in some countries, here some for your reference, in some countries, and some operator has already considered or has already launched the projects. And here we have an example of China. Till the year of 2020 in China, we need big number of cameras. This camera just for video surveillance, for the transmission line. Okay. We need a camera each 2.5 kilometer. Each 2.5 kilometer, there is one camera needed. And there are 20 million kilometers, totally 20 kilometers. So you can imagine how many cameras needed. And for the distribution network, there are around 20 million terminals. 20 million terminals like this station or site needed for the automation, communication. Okay. And there are 500 million of meters needed for the smart reading. Okay. And this one, new energy, for charging pile, for new energy vehicles charging. And there will be 4 million of these piles. Also need communication. So you can see this is a huge potential demand. I think this will be a very big point of the 5G economy.